Hey, we're looking at finding the sums of geometric series. On Friday, we looked at geometric sequences. Somebody remind me what's the difference between a sequence and a series?
Sequence is added, subtract,
Sequence you're multiplying.
that's from our minimum.
What's the difference between a sequence and a series?
One
Right? So which one's which?
Okay, that's 50-50 chance. Sequence is one series.
Alright, so sequence is just an ordered set of numbers. A series is those numbers added up. Okay? So Sakai got it correct. Alright, so today we're looking at finding the sums of geometric series. So we've got two formulas to begin with. We're going to end up with three. But to start, we're going to have two formulas for the sum of a geometric series. The first one is a sub 1 times 1 minus r to the nth power over 1 minus r. The second one is a sub 1 minus r times a sub n over 1 minus r. So the first one is a sub 1 times 1 minus r to the nth power over 1 minus r. The second one is a sub 1 minus r times a sub n over 1 minus r. So again, what does a sub 1 represent? First term. What does r represent?
It's like the ratio.
Ratio. And what does n represent? Number of terms. And what does a sub n represent? The last term. Alright. So that's everything on those two formulas. So let's get started. Alright, so I have this geometric series and I want the sum of the first 6 terms. So I want the sum of the first 6 terms of this series. So since I want the sum, that means I need to pick out one of those two formulas. Which one would you suggest? Why?
Because we don't have this.
We don't have a sub n, so the first one would be the good pick. So a sub 1 is 8, and then we have 1 minus r. How do we get r again?
So the second divided
Second divided by the first is what we're looking for. So 14 divided by 8. So that gives me 1.75. Or yes, 7 over 4 would work. And then I need to the nth power. What would n be in this case? 6 over 1 minus 1.74. Or sorry, 75. That's the number of terms that you're wanting, and since it wants the sum of the first 6 terms, that's why it's 6. All right, so what's the best way to put this in the calculator? What are we going to do? 8 parentheses, control divide. We're going to do 1 minus 1.75. We're going to raise that to the 6th, and then we're going to go to the bottom and do 1 minus 1.75. And we end up, we're going to round to 3 decimal places, so 295.710. Haley, what does 295.710 represent?
The sum of all of them put together.
More specifically, how many?
6 terms.
6. So if I had those 6 terms, if I wrote out each 6 terms and then I added those terms up, 295.710 is what we end up with. Okay. So pretty much you're just plugging into a formula. Next one. This time we have a sub 1 equals 3, A sub n equals 768. R equals -2. So we want to find the sum of this series.
Second formula,
Why?
because you given a sub n.
We have a sub n, so we want to use the second formula. So I want a sub 1, which is 3, minus r 768, and over 1 minus r. So 1 minus a -2. So I'm going to do control divide. I'm going to do 3 minus -2 times 768. I'm going to go to the bottom, and the bottom is just 3. So I press enter. We end up with 513. Blake, what does 513 represent?
513 is the sum of I know it's a sum.
It is a sum, and do we know how many terms are in this sum? No, we do not know. Can we find out?
Yes.
Yes, let's find out. How do we find out?
You get into a different form.
I need a different formula, that's correct. Which one do I want?
One of the first one we did.
One of the first ones we did on Friday. What's that one called? The explicit. Very good, Christian. So I had a sub 1 equals, or sorry, a sub n equals a sub 1 times r to the n minus 1. We want to use this formula to figure out what n is. So what can I fill out?
A sub n.
A sub n is 768. Gage, you with me?
Yep.
768, a sub 1 is 3. My r is -2, and n is what I'm looking for. So now what? Solve for n. So what do you want to do?
Subtract 3. Divide by 3.
Divide by 3. So 768 divided by 3 gives me 256 equals -2 to the n minus 1. Now what?
Divide by 2.
I cannot divide by 2.
You have to
Yes.
square. Or not square. What are we to square then?
Square root.
Find the root of 256.
Alright, we could do that. Let's do it a different way though. Because that would take a while. First hour was able to come up with it. What do we have to do?
You can use
We gotta get in by itself, so what do you want to do to head that direction? Nick, got any ideas?
What about -1?
First thing I gotta do is figure out a way to get in out of the exponent. Anybody remember how I can get in out of the exponent? What have we done this year that allows us to take something from the exponent and get it out of the exponent? Logs. So at this point, we want to take the natural. We want to take the natural log of both sides. We want to take the natural log of both sides. Once I do the natural log of both sides, then what can happen with that n minus 1? It can move it to the front. So I get the natural log of 256 equals n minus 1 times the natural log of -2. Now what's wrong with the natural log of -2? It can't be negative. So at this point, when you're doing this type of problem, go ahead and make that, if that number is negative, go ahead and make it positive. Because the fact that it's negative has no influence on finding n. So we go ahead and make it positive at this point. All right, what do we want to do next? Divide by the natural log of 2. Good. So I get the natural log of 256 divided by the natural log of 2 equals n minus 1. And then what do? Add. So I get the natural log of 256, natural log of 2 plus 1 equals n. And then I punch that in. Looks like Rachel's punching it in for us. What should n be? If we do this correctly, what should n be? What type of number should n be? What does n represent? Number of terms. So what does n have to be? Has to be positive, and it has to be a whole number. What did you end up with? We ended up with 9. So if you're solving for n and you get something that's a decimal, that's a dead giveaway that you did it incorrectly. So now, Blake, what does 513 represent?
513 is the sum of 9 terms.
Terms. Very good. So that is the sum of 9 terms. Nicely
Could
done.
go through all that on
Yes. It wasn't that bad.
I thought we wrote that.
It's okay, later.
That'll show up. That'll show up in another problem.
So do we have to know how many times are?
In that case, no, but that is something you're going to have to be able to do. Whoops. All right, so now our geometric series is written in summation notation, and we want to find the sum. And we can use either formula. Which formula would you like to use? Doesn't matter. You can use either one. First one. All right. So I need a sub 1, I need r, and I need n to be able to use the first one. So let's find a sub 1 first. Bobby, what do I do to find a sub 1? Very good. I plug 2 in. So I plug 2 in for k. When I plug 2 in for k, that makes my exponent 1. 5 to the first power is 5, and 5 times 3 gives me 15. So I know a sub 1 is 15. Next thing I want to do is find r. Can anybody look at this and tell me what r is?
It's R5.
R is 5. How'd you get 5, Christian?
I just remember that.
If you go back to the explicit formula,
Yeah.
notice where r is at. Inside the parenthesis. So that's how we notice that 5 is my r. Alright, and then I need n. Gage, do you remember how to find n? When it's in summation notation? Reagan, do you remember how to find n?
Is it the top minus the bottom plus 1?
Very good. Top minus the bottom plus 1. So 7 minus 2 is 5. 5 plus 1 gives me 6. So now we're ready to punch this in our calculator. So we're going to go 15, parentheses, control divide, 1 minus 5 raised to the 6th power over negative 4. And we end up with 58,590. Colleen, what does 58,590 represent? The sum of 6 terms. Very good. Sum of 6 terms. All right. So here's another geometric series written in summation notation that we want to find the sum of. It is a 0.5, 0.5. All right, so let's use the same formula. So Bree, what do I do to find a sub 1?
You plug in k.
Okay, so I plug 4 in for k, so that makes it 0.5 to the 3rd power. And then I multiply that by 120, and we end up with 15. Okay? The next thing I need to find is r. Kendrick, what's r going to be?
R is 0.5.
R is 0.5. And then I need to find n. Katie, what's n going to be?
Just call me Katie.
Sorry, Lauren.
It's gonna be. Wait, do you plug it into the formula thing,
I know.
or do you do 11 minus 4 plus 1?
There you go. 11 minus 4 plus 1. So that means n is going to be 8. So then I punch that in. So I'm going to do 15 parentheses. Control divide. I'm going to do 1 minus 0.5 raised to the 8th power over 1 minus 0.5 is just 0.5. So we'll get 29.882. Scott,
How'd you find
top minus bottom plus 1. 11 minus 4 plus 1. Alright, so 29.882. Kaylee represents what?
The sum of 8 terms.
Sum of 8 terms in this series, that's correct. Alright, now we have been dealing with finding finite sums. What do I mean by finite sums? We're finding sums of series of specific number of terms, correct? We can also find sum of infinite geometric series.
He said,
Okay, and that formula is S equals A sub 1 over 1 minus R, but there are restrictions on R. What does that tell me R must be?
Currently not real, but less than.
Between negative 1 and 1. R must be between
oh,
negative 1
I
and 1.
thought that was a K or something.
Yeah.
Yeah, that looks kind of.
So R must be between negative 1 and 1. If R is not between negative 1 and 1, you cannot find the sum of an infinite geometric series. You can only find the sum if R is between negative 1 and 1. Alright, so. Oops. So I want to find the sum of this infinite geometric series. Question. What do I have to do first to make sure I can find the sum? Check R. I need to figure out what R is. And what is R in this case? R is 1/3. So can I find the sum? Yes, I can find the sum. So my sum is going to be A sub 1, which is 9, over 1 minus R, which is 1/3 in this case. So now what do you recommend we do?
Get the fraction out of the
Multiply by 3? So if I do that, that gives me 27 on the top, and that gives me 3 minus 2 on the bottom, which means, 3 minus 1. Just thinking ahead. So that means the sum of that infinite geometric series is 27 over 2. Okay, but again, R has to be between negative 1 and 1. If it's not, you cannot find the sum. Okay?
How can you add something together that's
I'm glad you brought that up. Glad you asked that question. How can you get the sum of something that's infinite? So here's an example of how you can get the sum of something that's infinite. Alright, so I have 3 repeating, and what do we know 0.3 repeating is?
1/3.
We know that's 1/3. So what we want to do is we want to rewrite 0.3 as an infinite geometric series, and then we want to find the sum of it. But we know the sum of it has to be 1/3. So we're going to show that something that is infinite has a finite sum. So how can I rewrite this to where that it is a geometric series? how can I write that as a geometric series? One number plus something else, and to get from one number to the next, I'm multiplying. Outstanding, Nick. So 0.3 plus 0.03 plus 0.003 plus, and so on. Okay? So as you can see, does everybody agree when I add this up, I'm going to get this 0.3 repeated? Everybody agree with that?
Yes.
Okay? Now, to make sure that it's geometric, what do we have to do? Make sure that my R, to get from one number to the next, my R is the same. And how do we get R again? So the second number divided by the first number. So to get rid of the decimals, I need to multiply by 100. So that makes it 3 on the top, makes it 30 on the bottom, which means my R is 1/10. And that should make sense because each one of those is moving over one space, which means I'm multiplying by 1/10. So my R is 1/10. So now I've got everything I need to plug into my formula. So A sub 1 is my 0.3, and my R is 1/10. Alright, what do we want to do next? Multiply by 10. So that gives me 3 on the top and gives me 10 minus 1 on the bottom, which gives me 3 over 9, which is 1/3 like we said it was supposed to be. So yes, it does not make sense that you can find the sum in an infinite geometric series, but that right there proves that you can. Okay, yeah, it's messed up. Alright, one more example and then we're done. So I have this geometric series that goes from 4 to infinity, and my formula is 4 times 0.2 to the k minus 1. So everybody agree that this is an infinite geometric series? Because we've got the infinity sign up there that tells me, yes, it's infinite. Okay, does everybody agree that I can find the sum of this, and why am I allowed to find the sum of this? Not what I'm looking for.
Well, because R is
There we go, because R is 0.2. Okay, because remember, my R has to be between -1 and 1. My R in this case is 0.2, which fits that bill. Very nice, Bobby. Alright, so my sum, I need A sub 1 over 1 minus R. We've already pointed out that R is 0.2. So all I've got to find out is A sub 1. And AJ, what do I do to find A sub 1? Yeah, you do. Plug in 4. So I plug in 4. That makes my exponent 3. So I need 0.2 to the third. And then I need to multiply that by 4. That gives me 0.032. Alright. And then we punch that in our calculator. So control divide. We have 0.032. Divided by, that's going to be just 0.8 on the bottom, right? So we end up with 0.04 as the sum of our infinite geometric series. Okay, so there are your 3 formulas to find sum of geometric series. What type of sums can I find with my first 2 formulas? Finite, and on my last one, I can find infinite, but R has to be between -1 and 1. If it's not, you cannot find the sum. Not possible. Alright, so on page 615, we're going to do 40 to 64 even. And remember, when you get to these summation notations, what is the book going to have instead of K right here? N, Remember to replace that in with I, J, or K. That way you don't get confused. Also, tomorrow, these first 4 assignments, what do these first 4 assignments entail?
What's on the quiz?
What's on the quiz is correct, but what is it? What were we dealing with? Arithmetic sequences and arithmetic series. So you're gonna have a quiz of those first 4 tomorrow. That is arithmetic sequences and arithmetic series.
What?
Okay?